Okay. So this is the classified paper 4, topic 6, chemical reactions. So we have copper 2 oxide which react with a hydrochloric acid to form copper chloride and water. The rate of a reaction can be increased by increasing the concentration of a hydrochloric acid or by heating it. So either we increase the concentration of a hydrochloric acid or we can also heat it, so the rate of a reaction will increase. Explain in terms of the collision, explain why increasing a concentration of a hydrochloric acid increases the rate of reaction. So when we increase the concentration, why the rate of reaction? First thing, when you increase the concentration,
More collisions.
good. Increasing concentration, there are more particles
Volume, so more collisions.
in unit volume. So if there are more particles in unit volume, they will have a greater number of collisions. So as they will have a greater number of successful collision, it will have a faster rate.
This is for 3 months.
No, 2 marks. Rate already, because they specify here that the rate of a reaction increases with concentration and temperature.
Okay.
But you just have to mention increasing a concentration, more particles in a unit volume. As a result, there will be more collisions between them. Increasing concentration, more particles in a unit volume increases, because when we say concentration increase, say this is 5 particles, here also 5 particles. But which is a high concentration, A or B? A or B?
B.
B. More particles in a unit volume, like density, concentration concept is same like density. If we say density is higher, it means more particles in a unit volume. Next is explain in terms of collision. Explain in terms of collision why that heating the hydrochloric acid increases the rate.
Look, heating it will increase the temperature, so particles will have more energy and they will collide with more energy, and the rate of reaction will increase.
Good.
More particles have kinetic energy, so more collisions.
Greater proportion. Looks the same question, sometimes they mention in 2 marks, 3 marks, 4 marks, but answer remain the structure. So when we increase the temperature, what will happen?
Increase temperature, more kinetic energy, particles will move faster. So
increase in temperature, increase
kinetic energy.
The kinetic energy or speed, we can say that.
The third,
more collision, no, because kinetic energy and speed are related. If the kinetic energy increases, the speed will also increase. So more collisions, or the between the particles, or the collision frequency increases. Also, there will be a greater number of the particles with energy more than activation. Activation energy will not change. As a result, what will happen? The rate will increase. So whenever this is a structured answer, try to learn this. Don't try to lose the mark for such questions in which the repeated questions are there. So try to learn these answers. Try to learn the structure. Yes, learn. Try to learn the structure of the answer. Done? Okay. Increase in temperature increases the kinetic energy or speed, or the collision frequency increases. Greater number of particles with energy more than activation, so the rate will also increase. Same question you will find for 3 marks, same question you will find for 4 marks as well. The part B is actually related to the moles topic, empirical formula in moles. We'll move on to the next page. The next question, page 18. The reason why we skipped the remaining one is related to moles topic, as we'll do the moles. When barium carbonate is added to a dilute sulfuric acid, a carbon dioxide gas is formed. A student carried out the experiment to measure the volume of a gas as a reaction proceed. The student added a small pieces of a powdered barium carbonate to an excess of a 0.1 mole hydrochloric acid. So hydrochloric acid is in excess. and a barium carbonate is a limiting factor here. The volume of a gas, which gas will be released here if a barium carbonate react with hydrochloric acid? Which gas
Carbon
will be
dioxide.
good?
Carbon dioxide.
No. A metal carbonate react with acid. Which gas?
Sir, it is in the question. The answer.
Yeah, but some of them are not able to answer.
Carbon dioxide.
Carbon dioxide is given in the question. Barium carbonate is added to hydrochloric acid. A carbon dioxide gas is formed. Whenever a metal carbonate react with acid, it will be a carbon dioxide. If a metal react with an acid, hydrogen. And if an alkali react with ammonium salt, so it will give off ammonia gas.
Ammonia, salt, and water, right?
What is the meaning of term limiting factor? Whenever two reactants are used, one of the reactant, if we use more than enough, we called an excess, the other reactant will be a limiting reagent. Like example, when a barium carbonate is reacting with hydrochloric acid, it is producing barium chloride plus carbon dioxide plus water. So in the question they mentioned, we carried out a small barium carbonate to an excess. So we use this more and this is less. So the one which is less, that is a limiting factor or limiting reagent. So limiting reagent and excess are opposite of each other. Whenever two reactants are there, one of them is a limiting factor, other one will be an excess. Name two pieces of apparatus need to take the measurement shown on the graph. The measurement shown on the graph, we are measuring a volume of a gas and we are measuring a time. How to measure the volume of a gas?
Syringe.
Gas syringe.
Yes. And stopwatch.
Good. And how to measure a time?
Stopwatch.
Stopwatch. Stopwatch. Because you're measuring a volume of a gas in a time, so stopwatch and the gas syringe. On axis, sketch a graph how the rate of a reaction changes as the reaction proceeds. Assume initial rate of a reaction is represented by point X. Here, the next question.
Next question.
Look, if you see this, which point the reaction is fastest? At the beginning, because steeper slope. Then the reaction slowed down at around 120, the reaction has stopped.
It is constant.
No, it has volume of a gas is constant, but the reaction has stopped. No more reaction take place. Now we have to draw a graph for a rate and time. So in the beginning, the rate is highest. So it will start from X that they mentioned. Where it will end?
90.
No, 120, because in the question, if you see, when the volume graph was there at 120, it become horizontal line after 120. So we have to draw, and it is not a linear graph. Linear means like it's not a straight line graph, it is a curve, because in the beginning the reaction is fast and then the reaction slow down with a different rate. So we draw a curve from starting from position X till we reach 0.
So do we have to measure the line?
No, this is a sketch. Whenever the question is sketch without measurement.
Just see the graph, how it went.
Yeah.
Okay.
So if you see, this is the volume of a gas. This is the volume of the gas in time. In the question, we want to sketch a graph for rate and time. So on y-axis, we have a rate or the speed of the reaction. And on x-axis, we have a time. So at which point the reaction is fastest? It's at the beginning. So it means the reaction rate is maximum in the beginning. At which point the rate is 0? Rate means the speed. So rate is 0 here. We don't have to draw this. So at 120, the reaction is 0. And then what will happen? The reaction maximum in the beginning and then it slow down. So maximum in the beginning and then it slow down. So the value of the rate is decreasing. But it's not a linear change, it's a non-linear change. Is it clear? The speed of a reaction. So whenever we want to sketch a speed of a reaction in time, in the beginning, the reaction is always fast because there are more particles. But with the passage of the time, the rate or the speed of a reaction decreases. Any doubt in this?
No, sir.
Clear about this?
Yes, sir.
Why the at 1/22 the reaction is zero? Because at 1/22 it's a horizontal line. When it is a horizontal line, it means the reaction has stopped. Like this part, the reaction has stopped. And this part, the reaction is maximum, the rate. And here the rate is starting to decrease. That's why when we sketch a graph for a rate and time, so when we reach 120, the reaction is rate is zero. And this is a beginning. So the reaction rate decreases until we reach 120. Why we cannot draw a straight line here? Because it's not a linear change. It's not a constant change. If it was a constant change, then we'll draw a linear, like the straight line. This is a Mole's question. The original graph has been drawn again here. On a grid, draw a graph you expect if the same mass of a barium carbonate is added to large lumps of instead of powder. So if we use the same mass, so every condition things are all other conditions are same, but we are using a large pieces.
Reaction will be slow.
So what will happen? The reaction will be slower. So how we show a slower reaction? So it will be below the original. And in exam, how you will label? You can just label that as D. Because if you use a large pieces, the large pieces will have a small surface area, so the reaction will be slower. If you use a powder form, the powder will have a large surface area, so the reaction will be faster, but the final product will be same. Why the final product is same? Because you are using the same amount of reactant. The product will only change if we change the limiting factor, limiting reagent. If an excess reagent is changed, like in this beginning of the question, they may mention hydrochloric acid is in excess, like more than enough. So if I change the amount of hydrochloric acid, the rate of a reaction will change, but not the amount. If I change the limiting factor, then it will. If we change the limiting factor, that will change the amount of a product. No, in that case, we will draw much steeper. So in the question, they mention that this is a graph for a powder. A powder will react much faster. Now we have to sketch a graph for the lumps. The lumps will have a small surface area, so it will react slower. So when a reaction is slower, it is less steeper. So it will take longer time to complete. This will be the graph for D. So fine powdered will react much faster as compared to solid lumps. The next is the original graph has been drawn again. On the grid, draw a graph you expect if a concentration of a hydrochloric acid is changed from 0.1 to 0.2 and all other conditions kept same. Look, we use more concentrated hydrochloric acid, but see the beginning of question, which is in excess? Which reagent is in excess? Powdered barium carbonate to an excess of a hydrochloric acid. So hydrochloric acid is in excess. Whenever you change an excess reagent, it will not change the product, it will only change the rate. If I change the barium carbonate, then it will change the rate as well as the amount of product. So in this question, we increases the concentration from 0.1 to 0.2. So what will happen to rate? It will increase. But what will happen to the final product? It will be the same. Why it is same? Because you are changing an excess reagent. If you change the limiting reagent, like let's say we were changing barium carbonate. How much barium carbonate was used originally? It was 6 gram. Or they did not mention. I think the next part they mentioned something about. No, it's not mentioned. Let's say it was double. So if the barium carbonate was double, then what will happen? The amount of a product will also be double and the rate will be faster. So if you change a limiting factor, it will change the rate as well as the amount of a product.
If we lower the limiting reactor,
Then the amount of product will also decrease and the rate will also decrease. So this is a 4 marks. How you scored all the 4 marks? First, you will sketch a graph. Okay. 1 mark is for how you, 2 marks are actually for the graph. 1 mark is for steeper, 1 mark is for the same product. And then explanation is there because the access reagent is changed, like increasing the concentration, increase the number of the collagen, in unit area. As a result, the rate will also increase. And for the last part, so we have in the question, I'll repeat, see the reaction is between a barium carbonate and a hydrochloric acid, result in a formation of a barium chloride plus carbon dioxide plus water. That's the reaction. This one is a limiting reagent. I'm writing in short LR, limiting factor or limiting reagent. And this one is an access. Okay. So if we change this access, what will happen? Only thing what happen is the rate will change. But if we change the limiting factor, what will happen? It will change the rate and it will also if so I was disconnected about the last part. So in the last part, if we have a barium carbonate and it is reacting with a hydrochloric acid, this will result in a formation of a barium chloride plus carbon dioxide plus water. Now, hydrochloric acid, in the question they mention it is an access. And barium carbonate will be a limiting factor or a limiting reagent. So whenever, if you change the access reagent, it will only affect the rate, gradient. But when you change the limiting factor, it will affect two things. It will affect the rate and it will also affect the final product. How much product you get. So in the question, they mentioned that the hydrochloric acid concentration is double. It was 0.1 changed to 0.2. So if we increase the concentration of a hydrochloric acid, what will happen? So it will be steeper, like the rate will be higher, but the final product will remain same.
the rate will be same, but it will be
No, rate will be higher, but the final product will be same because we are changing an excess reagent, the hydrochloric acid. That is what they mention in the question. And the next one, the experiment is repeated. The experiment is changed and the mass of a powder barium carbonate is double. If I double the barium carbonate, what will happen now?
double the
More,
So
more
it will give,
product.
yeah, more product and a faster rate.
Yes.
So how much product is here? Like, what's the value? What is this value? 180, I guess.
No, it's 180 here.
180.
180. So if I double this, if I increase the barium carbonate, the reaction will be faster and I'll get more product. How much product I will get?
180 multiplied by
Multiple, because we double the
180
barium
multiplied by
carbonate, 180 multiplied by 2, so it will be 360. So somewhat it will be.
do we need to also
No, we don't have to draw this. I'm just drawing to explain the idea. We just have to state the value. So it will be around 360, double of 180. So that will be the graph. Steeper and a faster rate and more product. So the question is, what will happen to the mass? What will be the volume of a gas collected If we double the amount of a barium carbonate, so for this amount, we were getting 180. If we double the amount, if we double the barium carbonate, what will the amount? It will be 360. So we just have to write here. We don't have to draw for the last part that it will be 360 cm cube. Is it clear?
Yes, sir. You wrote 360.
Yeah.
Yeah, I thought like it's 16 centimeters.